All right, this is the last page of the review. We've got a ladder, 20-foot ladder going up against the building. The ladder's 12 feet away from the building, and it is falling down at a rate of 3 feet per second. We're trying to figure out how fast it's going here. So we need to find this other side, and you can do Pythagorean theorem to find that side, or if you know your 3, 4, 5, and multiples, Pythagorean triples, you could have maybe predicted that would be 16, because if you divide all of these by 4, you get 3, 4, 5, and that's always a Pythagorean triple. But either way, we get 16 for that. I'm going to label that A, that B, that C. And Pythagorean theorem says a squared plus b squared equals c squared, but our c doesn't change in this problem. Our c is always 20. And so we can leave anything that's not a variable that doesn't change, we can leave alone. Now let's go ahead and take the derivative of this. So 2a times dA dt plus 2b times dB dt equals the derivative of 400, which is 0. All right. And now we can put some stuff in. A is 16. The change in A is -3 because it's getting shorter. So it's decreasing at a rate of 3 feet per second. B is 12, and dB dt is the thing we're trying to find. Okay. So if I do this, I get -96. If I bring that over, I get 96 divided by 24. And if I do that, I end up with 4 as my rate of change. So 4 feet per second is how fast that's increasing or moving that direction. All right. And then the last one here, it has a conical tank pointed down, is 6 feet across the top. So that means the radius is 3 at that point, and 12 feet deep. So we're 12 feet total here. Water is flowing into the top of the tank at a rate of 14 cubic feet per minute. So 14 cubic feet per minute is the change in volume. dV dt equals 14 cubic feet per minute. Find the rate of change of the depth of water. So we're trying to find dH dt. That's our mission. When the water reaches a height of 7 feet. So that's our height that we're looking at. Okay. Now, the trouble here is that we've got two variables in here. We've got radius and we've got height. And we weren't given anything directly that talks about radius and height, but we can look at them. And what is true in the cone like this is when you look at this big rectangle that's 12 and 3, if you were to look at smaller versions of that, they're all similar triangles. In other words, the ratio of height to radius is always going to be the same. The height will always be 4 times the radius. 12 is 4 times 3. It doesn't matter at what level the water is. The height of the water will always be 4 times the radius. And because of that, you can put 4r in for h in this if we wanted to. But I don't want to do that because now the equation would be in terms of radius, and I'm trying to find the change in height. So I'm actually going to flip it around. I'm going to make my height be 1/4. The radius will equal 1/4 the height. And now I'm going to take that and I'm going to put that in for radius. So it gets a little clunky, but we're going to persevere here. Volume is 1/3 pi times radius squared, which we're going to now write as 1/4 h times h. So I'm going to have 1/3 times 1/4 squared. That's 1/3 times 1/16, which will give me 1/48 pi times h squared times h, which will be h cubed. And you're wondering, how the heck was I supposed to do this? Now, this is a very rare AP kind of problem. It used to be a little more popular for them to throw this kind of question on the test. Lately, they've been just kind of giving you a more direct formula to work with. But if this was the case, this is what we'd have to do to get here. Then we'd have to take the change in volume with respect to change in time is 1/48 times 3, which will be 1/16 pi h squared times dH dt. All right, we know h is 7, so we're going to put 7 in there. We know dH dt, we're not sure about that, but dV dt is 14. So now we're going to have 14 equals 1/16 pi times 7 squared times dH dt. All right, it's a lot of work, but now we know that dH dt is going to be 14 times 16 divided by pi and then divided by 49. And that's going to give me 1.455 feet per minute. Okay. Definitely on the hard end. Is that something we got to get excited about for our test? Probably not. In fact, I'm going to say no at all. But if you understand the logic here and what we did, that's good. All right. On your test, it'll be more like the other four that were a little more direct and straightforward.